Hello everybody, this is 6th grade math 7.1. Here's your contact email for PowerPoints or videos or quizzes, tests, and worksheets. 7.1 Ratios, rates, tables, and graphs. And using ratios and rates to solve problems, so we're going to use ratios and rates. 31 points for classwork, 4 points for the notebook work. Here is your bell work students as you come in the classroom. Homeschoolers, here's your warm-up here. Write the equivalent fractions, so we have 25 up here. What did we do to our numerator to get 25? Same thing here, same thing here, same thing here. What we did to our numerator, we have to do to our denominator. So I'd wait 5 minutes, 4 minutes, 3 minutes, 3.5 minutes, teachers. And then I'd have a student come to the smartboard or to the whiteboard to fill them in, or 4 students or something. Otherwise, you get 25 over 45, 20 over 24, 12 over 15, and then 20 over 36. Page 1, classwork, we have a reading. Start up here, and we visualize vocabulary here. Here's our vocabulary for this chapter here: pattern, point, rate, ratio, unit rate. Use the check words to complete the graphic here. Here's our graphic here. Rate in which the second quantity is 1 unit. So we have these blanks here that we have to fill in from our preview words here, or check words. So comparing unit rates, single item is a unit. Ratio of 2 quantities that have different units would be a rate. 2 quantities that have different units. Numbers that follow a rule would be a pattern. Rate in which the second quantity is 1 unit is a unit rate. Page 2 of your notebook, students. This goes in your notebook. Vocab words, review words, and then preview words. Here's the first time we've seen these would be conversion factors, proportion, scale, and then a scale drawing. And we have seen these words here before. Understanding our vocabulary, complete the sentences using the preview words. Here's our preview words again: conversion factor, proportion, scale, and scale drawing. A blank is a rate that compares two equivalent measures. So a conversion factor. In a scale drawing, the blank describes how the dimensions in the actual object compared to the dimensions in the drawing. The scale. Page 4 of our notebook. Essential question: how can you represent real-world problems involving ratios and rates with tables and graphs? How can you represent it with tables and graphs? And especially graphs, they're very much a visual part of math. All of mathematics is using a graph. Finding ratios from tables, but we have to enter data first, and they usually go into a table. We go from a table to a graph. The graph is the final product of a mathematical relationship. We have page 5 here in our classwork. Students in Mr. Webster's science classes are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. The table shows the amount of distilled water needed for various amounts of ammonia. So we have a proportion here between distilled water and ammonia. For every 2 milliliters, we have 50 of distilled water here of for ammonia. So what would be here, what would be here, what would be here, what would be here? If that proportion stays constant here. We have 5 here, yes. So for every milliliter, we have 50 milliliters of distilled water. That's kind of the relationship here. So for 3 milliliters of ammonia, 150, 3.5 would be 175. So what's 50 times this? 50 times that, 50 times that. And 50 times what equals 200. So it would be 4 here. Use the numbers in the first column of the table to write a ratio of distilled water to ammonia. So it's 100 to 2, or 50. This is 50, 100 to 2, and 150 to 3 would simplify to, this simplifies 50 here. It'd be 50 to 1 is what the ratio is here. How much distilled water is used for 1 milliliter of ammonia? So 50 milliliter. So it's 50 to 1, yes? Page 6 of classwork here. Here's our table that we used. Use your answer to write another ratio of distilled water to ammonia. Then we're going to use a fraction here, 50 over 1. And the ratios in A and B are equivalent. The ratios in A and B are equivalent or not equivalent. They're equivalent, aren't they? The ratios in A and B are equivalent. So 50 to 1 and 50 over 1, they are equivalent. How can you use your answer to B to find the amount of distilled water to add to give to a given amount of ammonia? So now a written answer is required here, a verbal model, which is used in algebra all the time. Sample answer, multiply the amount of ammonia by 50 over 1 or 50. Amount of ammonia here times 50 times 50 times 50 times 50 times 50. Okay, complete the table. What are the equivalent ratios shown in the table below? The equivalent ratios, 102, 100 over 2. So what goes over 3 to give us an equivalent ratio here? It's 150 here, 150 over 3. And then here, 175 over 3.5 equals what? 200. 200 over 4, and then 250 over 5. Look for a pattern. When the amount of ammonia increases by 1 milliliter, the amount of distilled water increases by, class, 50 milliliters. So 6 milliliters of ammonia requires blank milliliters of distilled water. How much? Be 300. Then we go into our homework here. Here is a table here that needs to be filled out. Class, you need to notice the ratios here between these two here. What are the equivalent ratios shown in the table? So you have 1, 2, 3, 4 entries here. 1, 2, 3, 4. And if you need more room, attach a answer sheet to this homework sheet. And this is worth 12 points here. Page 2 of our, actually this is homework, this is not classwork, this is homework. There it is, there's our homework. And it's 12 points here. We have a different table here, but we have a consistent ratio here. What are the equivalent ratios shown in the table? So students, do that. And this has been 7.1. of 6th grade math. Here's my contact email. If you need to talk to me about something or let me know, email me and I'll get back to you. Thank you very much. Have a great day.